Welcome back, and we're going to talk about 8.4, which is complex value trial solutions now. And before we dive into this problem, I guess not before, but as we're diving into this problem, I'm going to point out another method from 8.3 that you can use as well for these types of problems. And then I'm going to show you why you don't want to use the method from 8.3 because it just takes a really long time and it's even more computationally difficult than the computations that we have to do currently with the complex value trial solutions. So let's dive in. So this is the problem I have right here. Y double prime plus 2y prime plus 5y is equal to 4e to the negative x cosine 2x. And so step one, wrong colored pen. Step one is always to solve the homogeneous, right? So in order to do that, we got, oh boy, y double prime plus 2y prime plus 5y is equal to 0. Okay? And then what do we do? Well, okay, so then this means d squared plus 2d plus 5 applied to y is equal to 0. And so solving for d, we get d is equal to negative 2 plus or minus the square root of b squared, 4 minus 16, 20, all over 2a, which is 2. And so this is then negative 1 plus or minus 2i. Okay? And so now we go to step 2, which is to guess yp, right? And so now there are two ways to do it, right? There's the 8.3 way, which I'll talk about right now. And what is the 8.3 way? Okay, the 8.3 way tells us to look at this guy, which is the right-hand side is 4e to the negative x cosine 2x, right? And so now if we pull up our book, right? So here's our book, and we have this guy up here. We have this case right here, right? Where we have c x to the k e to the ax. And so we have 4 e to the x, e to the negative x cosine 2x. So I have this written on the left-hand side, right? And so what do? Well, we reduce that c is 4, k is 0, a is negative 1, and b is 2, right? And then what? Okay, so from that then we see that a plus ib in our case is equal to negative 1 plus 2i. Well, what's the problem? Well, if you remember, negative 1 plus 2i is actually... Oh man, this jumped over to the other screen. Let me pull it back. Negative 1 plus 2i is actually a root, right? Negative 1 plus 2i is a root. So what does that mean? Well, negative 1 plus 2i is a root with multiplicity 1, right? Because it shows up once in here. And so what the book tells me to do then, if I can find my mouse, okay, book tells me to do then is I want to take x to the m e to the ax, a naught cosine bx plus b naught sine bx. I want to add x a to the 1 cosine bx plus b to 1 sine bx plus blah 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 plus x to the k ak cosine bx plus bk sine bx. So essentially what I have then is I have cosine 2x plus sine 2x, right? So since my b again is 2, okay, so I have cosine 2x plus sine 2x, and then so this, right, look at the terms here, right? It's a naught and then a1 and then ak, and then here you have xk. So essentially sum these guys to whatever power x is. Well, we see that x is 0, or k, whatever power k is, right? In whatever number k is. And here we see that k is 0, which means then that we only need to take this term, the a naught plus b naught term. So then we have a naught plus b naught sine 2x, right? Okay, and then what do we need? Well, now we need x to the m e to the ax, which is simply x to the first, and so we don't need to write the 1, and then this is e to the negative 1 times x, so negative x, and that is going to be our guess for yp, okay? So our guess for yp then, going back here, is yp is equal to x e to the negative x times a naught cosine 2x plus b naught sine 2x. b naught sine 2x, right? And so if I split the screen here, haha, haha, right? And that's exactly what I get by following chapter 8.3, following the trial solutions in chapter 8.3. All right, and this works. There's nothing wrong with this, except now, okay, so let's multiply this out. This is now x e to the negative x, well, a naught x e to the negative x cosine 2x, plus b naught x e to the negative x sine 2x, right? And now, okay, so that's cool. That's yp. But now, what is yp prime? And you'll see why this turns into a disaster, because you got to take the derivative of this guy with respect to x and have 1, 2, 3 x terms in there, right? And so how do you take the derivative of this guy? Well, you'd have to hold these two guys constant and take the derivative of that guy, plus holding then these two guys constant and then taking the derivative of this middle guy, and then you have to hold the last two guys constant and take the derivative of the first guy, right? So you have to apply the product rule by holding everything constant except one term. And, okay, so that means you're going to have 3 separate sums, right, here, and then you're going to get 3 separate sums here, and you realize this thing gets ugly really quick, because now you have 6 sums, and guess what? You have to take another derivative. So you'll see why the 8-3 way, it works, sure. But if you really like taking derivatives, this is the way to go. However, it can get really messy real quick. And so that's where we bring in complex value trial solutions. So complex value trial solutions all right. So that's what this title of this section is, complex value trial. It tells you the following. It tells you the following. It's the following way. So remember, we have on the right-hand side, we had 4e to the negative x cosine 2x, right? And 4e negative x cosine 2x, okay, so right there. Okay, now I want to think. Now, complex value trial solutions tells me that, okay, if I just look at e to the negative x cosine 2x, all right, what is this a part of? Okay, what is e to the negative x cosine 2x a part of? And we realize that e to the negative x cosine 2x is a part of e to the negative 1 plus 2i times x, right? So this comes from e to the negative 1 plus 2ix. Because remember, e to the a plus bix is equal to e to the ax times cosine bx plus I sine bx. So in our case, e to the negative 1 plus 2ix is equal to e to the negative 1 times x cosine 2x plus I sine 2x, right? And here you see clearly that this is then e to the negative x cosine 2x plus I e to the negative x sine 2x, and you see clearly that e to the negative x cosine 2x is a part of this guy, right? And so, okay, that's cool. And so what does that mean? Well, now that means that I want to guess yp to equal some constant, let's say a, times e to the negative 1 plus 2ix. Except there's a problem, right? There's a problem because negative 1 plus 2i is a root, right? Is a root. Negative 1 plus 2i is in here. So what do? Well, we do everything else, like the exact same thing we did previously when there's a root there, is that we add an x, right? So now this is ax e to the negative 1 plus 2ix. And the x is very important because if you don't have the x, then you're in the homogeneous solution, right? A times e to the negative 1 plus 2ix is simply a homogeneous solution, and so you need the x to make sure that it's not homogeneous. Okay. So cool. We got our guess now. Yp is equal to a to the x e to the negative 1 plus 2ix. All right. And again, we have this extra x in here because negative 1 plus 2I is a root. Okay, good. Now we take derivatives like usual. So yp prime is equal to what? Okay. So now we have take the derivative of x first. And so that's a e to the negative 1 plus 2ix. And then now we got to take the derivative of e to the negative 1 plus 2ix while holding x constant. And that's not bad because that's just negative 1 plus 2i ax e to the negative 1 plus 2ix, right? Okay, not bad because we only have two terms, while on the other one we would have had six, right? In the other solution, in the 8-3 method. And now, okay, now we take another derivative. So we take the derivative of this guy first, which then we just drop negative 1 plus 2i down. And so now we got this. Okay, so we just bring down the negative 1 plus 2ix because that's how we take derivatives of e to the something. And then now, all right, this guy over here, what is it? Well, we know what the derivative of this guy was, right? We know the derivative. We know what the derivative of ax e to the negative 1 plus 2ix was. It's right here, right? So the derivative of ax e to the negative 1 plus 2ix is just yp prime. And so now this just becomes then negative 1 plus 2i times yp prime, which is a e to the negative 1 plus 2ix plus negative 1 plus 2i ax e to the negative 1 plus 2ix. All right, so now let's simplify. What do I get? So now this is negative 1 plus 2i ae to the negative 1 plus 2ix plus, and this is now negative 1 plus 2i ae to the negative 1 plus 2ix plus, and now I got negative 1 plus 2i times negative 1 plus 2i. And so work that out on the side. Negative 1 plus 2i, negative 1 plus 2i. Foiling, you get 1 minus 2i plus 4i squared. So this is 1 minus 2i, or 1 minus 2i minus 2i minus 4, because I squared is negative 1. So this is negative 3 minus 4i. Okay, so now we get negative 3 minus 4i times ax e to the negative 1 plus 2ix. Okay, and now simplifying and gathering like terms, we got negative 2 plus 4, negative 2 plus 4i, ae to the negative 1 plus 2ix plus negative 3 minus 4i ax e to the negative 1 plus 2ix. Okay? And, okay, so that's what we have over there. Cool. Now, we got to plug these in. So step 3 is to plug into the original equation, which, if you don't remember, was y double prime plus 2y prime plus 5y equals 4e to the negative x cosine 2x. All right. And so, okay, so we get negative 2, negative 2 plus 4i ae to the negative 1 plus 2ix plus negative 3 minus 4i ax e to the negative 1 plus 2ix. All right, plus 2 times yp prime, which is 2 times ae to the negative 1 plus 2ix plus negative 1 plus 2i ax e to the negative 1 plus 2ix. Okay, so that's a big parentheses there. And then plus 5y, which is then, let's move it down here, plus 5yp, which is 5ax. So there's yp right here. So this is 5ax e to the negative 1 plus 2ix. All right. and this is all equal to 4e to the negative x cosine 2x. So, okay, this is pretty bad. Like, I'm not gonna lie, this is pretty bad. This is a lot of algebra to keep track of, and but like I said, it's even worse if you did it the other way. So you're just gonna have to bear with me here. And so what do I get? All right. Well, hopefully I didn't screw anything up here. I really hope I didn't. Okay, so I get. Okay, so I'm going to distribute the 2. So now this is 2 times a e to the negative 1 plus 2ix. And then this becomes then negative 2 plus 4. Okay? Right, because this originally was 2 times, rewind the video, and I just distribute the 2 in. So now that big parentheses is gone. The big parentheses outside is gone. I multiply the 2 through. Okay, what do I get? Well, you'll see here is a 2a e to the negative 1 plus 2ix, and here is a negative 2a e to the negative 1 plus 2ix. So the positive 2 and the negative 2, they kill each other. All right, so those guys cancel out. Here I got a positive 4i ax to the negative e to the negative 1 plus 2ix. And here I got negative positive 4i. But that's the wrong one. That's an x. Okay, that doesn't matter. Oh, yeah, here I got a positive 4i, and then here I got a negative 4i, right? Ax e to the negative 1 plus 2ix. So the negative 4 and the positive 4i, they kill each other. All right, what else? So here I got negative 3ax, and then minus 2. So these guys give me a negative 5, and then here I have a positive 5, ax e to the negative 1 ax. So here I got negative 5 ax, and here I got a positive 5 ax. So this guy kills then, and so I'll slash this way. That guy kills this guy and this guy together. And all I'm left with then is positive 4i. So I'm left with 4i ae to the negative 1 plus 2ix is equal to 4e to the negative x cosine 2x. But we want to write this right-hand side as we did up here. So we want to write the right-hand side like this right here. So we want to write it essentially as 4, right, e to the 4e to the negative 1 plus 2ix. So instead of this guy, we want to write this as 4e to the negative 1 plus 2ix. Okay? And again, I hope you see why this guy and this guy, they're equivalent. All right? And so to solve, now we got to solve for a. So a is simply equal to 4 over 4i, since this e to the negative 1 plus 2ix stuff all cancel out, right? So that cancels out. And so now a is equal to what? A is equal to negative I. Okay, so if you multiply the top and bottom by the conjugate, you get negative I. And then of course, 4 over 4i is 1 over I, right? Okay, so now you can multiply by a conjugate. And so a is equal to negative I, which now tells me that yp, this guy up here, originally was then negative ix e to the negative 1 plus 2ix. Right, so yp was negative ix a e to the negative 1 plus 2ix. Except what's the problem? You can't leave this as a solution because my right-hand side originally had a cosine, right? The right-hand side originally had a cosine term. So the last step then, step 4, and I know in the previous steps there are like only 4 steps, so this one actually has 5 steps, is then to write yp in terms of sine and cosine. All right, and now what? Now, so this becomes negative ix a, or there's no more a because a is negative I. Whoops. So this is actually just straight up negative ix e to the negative 1 plus 2ix. Remember, I solved for a, so a disappears. It's now negative I. So this is negative ix e to the negative 1 plus 2ix, which is equal to negative ix times what? It's negative e to the negative x times cosine 2x plus I sine 2x. Okay, so we rewrote this out again right here. We rewrote this out again because we now need to express e to the negative 1 plus 2ix as sines and cosines, right? And now I just multiply this out, and what do I get? I get negative ix e to the negative x cosine 2x, and then here I get minus I squared, but that's actually plus 1. So now I get plus x e to the negative x sine 2x, all right, by distributing. And that's because, again, this negative I and the positive I, they equal 1. All right. So now, are we done? Are we done finding yp, right? So yp is equal to this. And the answer is still we're not done finding yp. And why is that? It's because this guy, we took cosine 2x. All right? This is very important. If the right-hand side has cosine, all right? If right-hand side is cosine, we take the real term. If the right-hand side was sine, in this case it's not, right? Because my right-hand side, again, is 4e to the negative x cosine 2x. Right? This is my right-hand side. Okay. If the right-hand side was sine, then we take the imaginary term. So in our case, we take the real term, which is the term that doesn't have an I in front of it. So we take this guy. All right. So yp is actually just simply x e to the negative x sine 2x. And this might not sit well with you that we simply just ignore half of our answer. It's because we can create a linear combination to get this answer. That's essentially what it boils down to. And so yp is x e to the negative x sine 2x. Now, let's talk about the second scenario. All right. The second scenario didn't actually happen here, but this is a hypothetical. Okay, this is hypothetical here. What does taking the imaginary term mean, right? Because this is the imaginary term, the imaginary term. It means taking not ix e to the x cosine 2x. You can't have an I, right? Because nothing in my right hand. So in this scenario, in this hypothetical, again, this is an if I had 4e to the negative x sine 2x, right? There's nothing in 4e to the negative x sine 2x that would have an I in it, right? There's nothing here that has an I. So I drop the I, and yp would equal this, right? So again, what am I saying here? What I'm saying is that in this equation up here, right, if the right-hand side, instead of being 4e to the negative x cosine 2x, was 4e to the negative x sine 2x, first of all, verify that everything is the same. Every step that I took here is the same, would be the same, right? Every step that I took would be the same. Except at the last step, now our right-hand side, again, hypothetical, not the actual problem, our right-hand side is this, which means I would take the imaginary term, x e to the x cosine 2x. But because our right-hand side is real, it's 4e to the negative x cosine 2x, it's the cosine term, not the sine term. Right? It's the cosine term. Our yp is x e to the x sine 2x. Okay? Hopefully that makes sense. Again, ask a teacher or someone if that doesn't make sense. So part 5, we throw it all together. All right. And so now we take our homogeneous, which is, so this homogeneous is actually a e to the negative x. So the complementary, or the homogeneous, a e to the negative x cosine bx plus b e to the negative x sine bx. So b is 2, right? So now our general solution y is equal to a e to the negative x cosine 2x plus b e to the negative x sine 2x plus x e to the negative x sine 2x. And this is the general solution, where you have the homogeneous plus the particular. And you can see why complex value trial solutions are by far one of the most messy things to do. It makes a very messy thing only slightly less messier. And I know that many of you guys don't want to deal with imaginary terms, but I think I have it on my website that like some like prerequisites are like complex numbers. It's just really, you just need to get used to complex numbers really quickly. And they're just like foiling, polynomials of degree 1. That's really what they are. So, okay, cool. So this was complex value trial solutions. I think I'm going to skip the next chapter on springs. I'm not a big fan of springs. I just the kind of problems that springs pose vary very differently, like vary from professor to professor. And so I don't like springs. I'm not gonna cover springs. So actually, what I'm gonna do is I'm actually gonna jump to I think 8.7 now, which is variation parameters, which is an optional topic, but I feel like it's very useful, and so we can cover that. And then we'll cover 8.8, which is Cauchy-Euler, which is also a optional topic that I find useful and some professors like. And then the granddaddy of them all from this chapter is the reduction of order, which is even more of a mess than this is, than complex value trial. I think complex value trial might be more messy than 8.9, but that's what I'm going to do. So I'm going to skip 8.5. I'm going to go through 8.7, 8.8, 8.9. That's going to be it for differential equations. And then on to chapter 9, which is really quick, and that's about 240.